Alright, this is a review for the Algebra 2 Unit 2 Lesson 7 project. I encourage you to pause the video after each question demonstration and then answer the question in the project itself. Alright, so Lesson 7 is about writing and solving linear equations. Alright, equations of lines can be used to model situations that involve distance, rate, and time. You may have seen the formula distance equals rate times time. A line can be used to model this situation when the rate is constant. The rate or speed of a car is measured in miles per hour in the United States. Alright, so let's take a look at some distance versus times graphs. Alright, so in this case over here we have the distance measured in meters on the y-axis and the time measured in seconds on the x-axis. And in this case over here, we still have distance versus time. In this case, we're talking about kilometers versus h. Notice that in this case, the distance is the vertical axis and time is the horizontal axis. Therefore, the speed of an object is the change in distance over the change in time, which is the slope of a line. So for example, take a look at this distance versus time graph. Here we have a change in position of 20 and a change in time of 2, so that the distance, right, or the rate that this object is traveling at is the distance that it traveled, 20, the change in distance, divided by the time it took to travel that distance, which is 2. So 20 divided by 2 is 10. Since the units here are in meters and seconds, it would be 10 meters per second. In short, just a summary, the speed of an object is equal to the slope of a line when it's written in slope-intercept form. All right, so questions 1 and 2. The speed limit on a stretch of freeway is 65 miles per hour. Officer James T. Kirk clocks a car going 85 miles per hour 1/2 mile ahead of him. Suppose you wish to write the slope-intercept form of the linear equation that represents the car's distance from Officer Kirk over time. What is the coefficient for x? Alright, so what they're talking about is the coefficient for x when we're writing a linear equation y equals mx plus b form, right, known as slope-intercept form that you guys learned about in the previous unit. All right, the m here is the coefficient of x. And remember that m represents the slope. In this particular problem, the slope that we just discussed in the last slide is equal to the speed of an object. All right, so in this case, the car is going 85 miles per hour, so the coefficient for x, or the slope of this line, is going to be 85. Now we can see that what part of the line this represents, part B here, it represents the slope, because remember m, the coefficient of x, also represents the slope in a linear equation. All right, so that's question 1 in your project. What is the constant term? All right, when we're dealing with y equals mx plus b, the b, the number that's at the end, is the constant term. In the context of a word problem, it usually represents the initial value or starting value of something. In this case, the car is 1/2 mile ahead of Officer Kirk. All right, so in this case, the constant term here is going to be 1/2. And what part of the line does that represent? Well, it represents the y-intercept. All right, so those are questions 1 and 2. Question 3 then just asks us to write the equation of that line in slope-intercept form. All right, so we know that y is equal to mx plus b. The slope of this line is equal to the speed of the vehicle, which is 85. And the y-intercept is the initial starting value of that vehicle. And since it's 1/2 mile ahead of Officer Kirk, then that starting point is 1/2. Alright, so we just used the information from the previous question to write the equation into slope-intercept form. So in order to use this, if I wanted to calculate how far this vehicle was from Officer Kirk after 2 hours, I would just plug in a 2 right here for the x. And then I would do 85 times 2 and add a half, and that's how many miles this vehicle would be away from Officer Kirk. Alright, so question 4 asks, due to budget cuts, the officers now need to use stopwatches in a fixed location to calculate the speed of vehicles. Suppose Officer Kirk observes that it takes a car 20 seconds or 1/180th of an hour to travel half a mile. How can we use this information to find the speed of the car? Then it wants you to write an equation that models that situation. Then it asks you, what is the speed of the car? And if the speed limit is, in this case, 65 miles per hour, is the car speeding? Alright, so I'm going to go ahead and start trying to write the equation of the line first. So remember, we're trying to write an equation that's y equals mx plus b. Well, we need to find the slope of this line, right, which remember is the speed at which that car is traveling. And we need to find the y-intercept. Alright, so basically I like to draw a picture when trying to figure these things out. So let's say we have here's Officer Kirk on his motorcycle. Yay, there's Officer Kirk. He doesn't have his radar gun this time, right? So he just has a stopwatch. And so what's happening here is, right as this vehicle, he's standing next to the freeway here, and a vehicle passes him. And right as the vehicle passes him, he starts his stopwatch. Alright, so the y-intercept, right, would be the initial value when he started that stopwatch. And in this case, it's going to be at 0. Okay, that's the initial value. Then this car travels for half a mile, it tells us. So 1/2 mile. And then Officer Kirk clicks his stopwatch again. And he noticed that took him 20 seconds. All right. So that took him 20 seconds to travel half a mile. So now we're going to go ahead and try to figure out then the speed of the vehicle in miles per hour. Well, initially they gave us the time that it took this car to travel in seconds. And then you notice the problem went ahead and for your convenience converted 20 seconds into hours. We need to have the same units here, and since we want to know if the car is speeding in miles per hour, we need our units to be in both miles and in hours, not seconds. Alright, so we're trying to figure out here the slope. And if you may have seen that if we have 2 points on a graph, we can use the slope formula to calculate the slope. Now remember here, our points are going to be represented as time for our x variable and distance for our y variable. So at time 0, the vehicle is 0 miles away from Kirk, because that's when he starts his stopwatch. Then 1/180th of an hour later, so that's this number, 1/180, the vehicle has traveled half a mile. Alright, so now we can use these 2 points, right, on this line here to calculate the slope. Then we can go ahead and write our equation in slope-intercept form. So to figure out the slope given 2 points, we use the slope formula, which is we subtract the y-coordinates. So we say y2 minus y1, the difference in y-coordinates divided by the difference in x-coordinates. Alright, so in this case, I'm going to go ahead and call this second point here y2. Right, so this is going to be our y-coordinate of point 2. This is our x-coordinate of point 2. This is our y-coordinate of point 1. And this is our x-coordinate of point 1. So now if I plug those values into the formula, I get 1/2 minus 0 divided by 1 over 180 minus 0. Alright, so then that works out to be 1/2 divided by 1 over 180. So it's a fraction divided by another fraction. Alright, so when we're dividing fractions, we take our first fraction, we keep it the same, then we flip or take the reciprocal of whatever we're dividing by. In this case it's 1 over 180, so to find the reciprocal of that I would flip it over and I'd have 180 over 1. And we change divide into multiply. So that's basically how you guys have been taught to divide fractions, right, for a long time now. So now I can multiply straight across and I'd get 180 divided by 2, which in this case is equal to 90. That means this car is traveling at 90 miles per hour, right? And this is the speed and it represents the slope in our slope-intercept equation. So now we can go ahead and write the equation as y equals 90x plus 0. Right, so we don't need to add the plus 0. So this is the equation that represents this car's distance from Officer Kirk over time x, which is in hours. Let me go back to it here. And the car, as we can see, if this is the slope and it's the speed, then the car's traveling at 90 miles per hour. So if the speed limit is 65 miles an hour, then we can say that yes, the car is speeding.